So in the Google Colab, I also give you the regular expression using spacing. So there is a new library named spacing. I will give you some examples about this one. So things like dates, times, IP address. So this is also something complicated. This is something actually consistent because if you look at the IP address, it contains of 4 places, and for each places it contains 3 numbers: 999, 999, 999, and 999. And the maximum numbers here is 255. 255. It is because of the bit character in the computer. So this is the IP4. If you use the IP6, it will be different. So some researchers, they mentioned that this kind of IP4 is more consistent. But in IP6, there might be some fairly consistent. So some things that might be a little bit different. And yeah, using the regular expression, there are some limitations. So that's why the spacey give you they mentioned that they have a better formatting for filtering the words, filtering the characters. So fortunately, the spacey has easy ways to implement rejects in 3 pipelines: matches, phrase matches, and entity ruler. So we can see later the example with the entity ruler. And if you want to compare with other examples, so you can check this thing for your reference. Now let's see. So I skipped the first part. Now let's have a look at the more variation. So let's say I have a text 8 times before 11:45 a.m. So I want to find every words, okay, A from Z, lowercase, and A to Z for the uppercase. So I want to check only the text. Okay? So like 8, 11, colon, 45, it will be removed. And you will see only the text. So yes, there is at least one match. If you want to check whether it has character with plus, okay, so because we have no plus here, then it shows nothing. You can combine. For example, I want to know a digit and I want to know any character of minus or plus. Then we have only numbers. There is no minus, there is no plus. If you want to check phone number, so people can write the phone number like this one: 010-1234-5678. Then it means this is a phone number. You need to omit the dash. So we can find all the dash and check how many dash do we have. Okay, so we check there are 2 dash. Or if you want to check all the words, if we want to check also the dash. So we want to check the dash or the plus symbol and then followed by any digit. We'll see. Okay, 010. Okay, we have dash 1. And then we have dash 5. So we combine it with this find function. So this is some more variation. If you want to get the text, get something complicated like this one. What is it? Actually, this is a text. Some invalid text, but it has noise. It has at and it has n symbol. So you can find that omit the symbol and then only get the clean by looking at only and by looking at only the alphabet and digit. Then it becomes like this one, some invalid text, and then this will be removed and this will be removed. Or in some cases, yeah, if you put the string like this one, call me at 412555123 4. So you want to extract only the phone numbers. So you do not want to get this one. Okay, then you can get the RE, search for the R where the digit contain 3 at the first and then followed by a dash and then another digit which is 3 digits and then followed by dash and the last digit will be 4. Then you can group it and put it into the numbers. Then you will get this number. And this is the full number. You can extract only the full numbers without the characters. So that's another library, as I mentioned to you, the Spacey. Spacey is also one of the natural language library. It can be used for the regular expression. So you can use later for the NER and etc. I will explain later. Now let's look at the Spacey, how we can use the Spacey for regular expression. First, we can import, and let's say we have a sample like this one, 5555555. So Spacey is a library that can be used for many kind of languages. So you can use it also for Korean. You can use also for Spanish, French, Polish, Russian, Japanese, and etc. So they have a lot of language libraries. Now let's suppose I'm going to use it for English. So as I mentioned to you, there are some pipes. So there are 3 pipes: measures, phrase measures, empathy ruler. Maybe this is not, I will not teach all the things. So let's just make it with the empathy ruler type. Now let's figure out how we can match the patterns. I hope by now you understand the Python syntax, the list, library, set, and etc. So in this case, we are looking at the key from the dictionary. So if it is available with phone number, so that's why we call it the entity rule. There is a rule for this one. If the label is phone number, or if we have a pattern where the shape is DDD or digit, or if we have the ORTH with yes, or if we have the OP, yeah, this is also a kind of short for the foot, or the shape is DDDD with 4 digits. So we can specify this pattern. So you can make your own rules. Okay, this is just an example. And after we have this rule, we want to add this pattern, this rule into the ruler. And then let's check the text based on your rule. So this is a sample number 555555. So the pattern you can see here we have 3 digit and we have 4 digit. So yeah, this is the 3 digit and we have 4 digit. So this is one number. We can use the regular expression with the digit like this one. We want to find the digit 3, we want to find the digit 4. Okay. So this is the way to use the regular expression. And this is the way to use the spacey. Which one is better? It's up to you. Okay. You can use spacey, the result like this one. The same with the regular expression, the result will be like this one. Yeah. Every library, yeah, is good. It has advantages and it has disadvantages. So you can choose which one is better for you. So this is another way to make the patterns. Okay. So you can combine the patterns with the regular expression. So it means you can combine the spacey, you make the entity rule, and the text or the patterns that you are using is based on the regular expression. And you are giving the regular expression like the RE, like X/D. So it consists of 3 digits. X/D, it contains of 4 digits. So this is also the same. Oh, wait. Um, hmm, Let me check later why it doesn't work with the rejects. No. So actually it can be combined with the rejects. So this is from the regular expression. We need to look at the RE because we already have the RE. Hmm. If we put the R, this is, let's see. It doesn't work. Okay, let me check this one. This could. Okay, let me just skip this one and then yeah, the other kind of spacing we can use for the similar like the rejects. Not sure if this reject is working or not. Okay, so this is another kind of example using the spacey. We can apply the entity ruler, not using the add patterns like this one. We are not using the add type for the entity ruler, but we can just call the pipeline. So the pipeline means this is the function entity ruler, not the package. And yeah, we call what language that we are going to use. In this case, it's English. Then yeah, the NLP will be based on the English. So we can set the patterns. I will take a look again on this one. So for example, this is a rejects. We want to get apples. So any word apples, A is the beginning. So it can be big letter of A or small letter of A. And then we have P, P, L. Either apple is ending with E or ending with ES. So we can have the word apple like this one. We can the word apple. We can have apples with S, or we can have apples like this one. So if we can see the word like this one, then we will extract it. So here the other pattern is Granny Smith. So this is the type of apple. The type of apple, we have the apple, red apple, Granny Smith, and etc. Then if we use the NLP part, we can extract this one, because in English, whenever you put a name, when you write a name, you will make the name with a big letter at the beginning of the word. So we have Granny like this. Smith, S. This one. So in order to make the patterns, we want to see the lowercase. We want to see the lowercase. Yeah, I think there's something wrong with the regular expression. Let me check later with the regular expression. Now it has empty. Yeah, I will check later about this one. So which one is better? Regular expression or the spacey? It's up to you to use. If the more updated version, you can use spacey, and spacey is also available for the Korean language. Okay. I will explain with examples later. So the next about the text preprocessing is about the syntax analysis. What is syntax analysis? When we are dealing with the syntax analysis, it means we are looking at the process of analyzing a string of symbols conforming to the rules of a formal grammar. So any language, we can see the grammar, 문법. In English, you have the grammar, subject, verb, and object. So in Korean, you have the grammar, subject, object, and verb. So in the syntax analysis, we want to find whether the word belongs to subject, whether the word belongs to verb, or whether the word belongs to object. And we can predict. So for example, in English, you can see it starts with a sentence, and we can split the sentence. So here, NP. NP means the noun phrase. So there is a noun, and there is another noun. Sorry, this is VP. This is verb phrase. So the noun is the word I. In the verb phrase, we have the verb which is love. And NP, it is a noun, which is you. So the word I love you, we can identify it is a noun, it is a verb, and it is a noun. So when we do with the syntax analysis, we need to do parser. Parse. This is from the word parse. Means it is an algorithm that computes a structure for an input string given a grammar. So all parsers have two fundamental properties. Okay, so we will check this one. It can be represented with tree. It can be represented with list. If it is a tree representation, then you will see like this one. If I have the word John ate the apple. So John, it will be indicated as name. Okay, this is a noun. Also, ate. This is the second form, historical form or the Guango. So it is a verb. The is just a kind of to explain the apple. So apple is another noun. Then it is a noun phrase. Or we can make it as a list. As a list, we can define S is a sentence, and then John. John is a name, and it is a noun. It is a verb, and it is in the verb phrase. The is explainable for the noun, and then apple is the noun, and those two belongs in the noun phrase. Okay, so this is the meaning. The issue in the syntax analysis is not a single parsing tree due to the language ambiguity. If the word is simple, yeah, maybe you can easily get the noun, verb, and hetero. But when the word is too complex and if the sentence is too long, then it will make some ambiguity. Because the lexical ambiguity, one word can be used for multi-part of speech. Lexical ambiguity causes structural ambiguity. So for example, time flies like an arrow. If you understand this one, okay, we can look at time. This is a subject, which is a noun. Flies. It's like a verb. We want to fly from the word fly. Like an arrow. Like an arrow, it is a proposition to describe a noun. Arrow. But there is another possibility to make like this one. Time is an adverb. It is possible as an adverb. And flies, it can be a noun. What is it? Flies, it can be Korean hari. The word flies is also representing hari. Then, whether it is a verb or is it a noun, it depends on the parser. So we call this is the language ambiguity. Like in this case, we can define it as a verb. So this is a verb phrase, and in this case, we are defining as a noun phrase. But here we defining as another proposition. So this thing can happen when you do with the syntax analysis. And also the structural. The structural can have also some ambiguity. One sentence can be understood in different ways. For example, John saw Mary in the park. Now, is John in the park? We are not sure. So we can say that John and Mary, actually they are in the park. So John and Mary in the park. So John saw Mary in the park. But there is also another kind of ambiguity. John is not in the park. But he saw Mary when Mary was in the pub. So that kind of things, it can be understood in different ways. So the syntax analysis, we need to figure out what is the correct meaning of this word. When we deal with the context with this kind of different understanding, the structure will be also different. So if you look at this one, this verb phrase represent that John saw Mary in the pub. And then this, representing saw Mary because John is in the pub, so he saw Mary. But in this case, the structural John saw, he just saw, but actually John was not in the pub. John is outside the pub, but he saw Mary in the pub. So this is the structural ambiguity. There are many more, okay, for the syntax analysis. We call it, this is part of speech, part of speech, or they call it POS. Whenever you have a word like this one, they will put it into one kind of tag. This is noun, and so on. And there is another kind of analysis, we call it name entity recognition. So if we look at this word Clinton, okay, this is about person. Previously, Johnny, then this is about they. Obama, okay, this is about person. Now, okay, this is they. Or there can be another kind of analysis, co-reference. Co-reference. So Mrs. Clinton previously worked for Mr. Obama, but she, then there is a reference. She refers to Mrs. Clinton. So Mrs. Clinton previously worked for Mr. Obama, but she's now distancing herself from him. Okay. So herself also has a co-reference with she, him has a co-reference with Obama. So if you are trying to make the analysis, the correlationship between those words, then we can make a good sentence or a better sentence, or we can make some analysis whether this sentence is correct or not. And some basic dependency. Okay, so this is more complicated. If we have a subject, whether it is followed by verb, it is followed with object, and the object is a compound object, and so on. So the first is about the POS, part of speech. When we are dealing with the part of speech, it is a process of assigning a grammatical category. Grammatical category. So as I mentioned to you, the subject, verb, object, and etc. So we call this is a part of speech. So this will be applied to its word. For example, it identifies whether a word is a noun, it is a verb, adjective, or adverb, and so on. It is a kind of structured prediction. So in the POS, they already defined what are the POS based on the computational language. So in English, they have like, for example, PRP. It is the personal pronoun. So in this case, I like to read books. So I is the personal pronoun. Like is VBP. VBP is verb. non-third person singular present. Two, just a two. Read. This is Phoebe. It is verb as the base form, and books and s. It is a noun where the noun is plural. So this is a predefined. So someone already defined this one, and we need to match for every words, whether it belongs to PRP or VBP or two, or this is VB or this is NNS. Different POS tags for the same token. So I can have the word I love you. So love means, in this case, is a verb. But all you need is love. In this case, is a noun. So this kind of different text will make a different analysis. There are many algorithms to do the post taking. Okay? So you need to do the training. So the training is a manually annotated corpus is processed by a machine learning algorithm. So there are many algorithms that you can use, and they have already the corpus. We call it corpus. And the tagging algorithms, it is processing the text using the learn parameters. I will not discuss in detail about the post tagging, but we can use the decision tree, we can use the hidden Markov, we can use the SVM, we can use the transformation based taggers, and etc. for the post tagging algorithm. So some people, they already make the category. The POS, we can use the point-wise prediction. Point, that's meant by the point. So we pointing its of the word. Its of the word. So for example, I have a training set. I can see, I can swim, the fish can swim. So we need to make the data something like this one. So the word is I, and the tag is PRP. The word is can, and the tag is MD, model form. The word is sing. So this is VB, verb as the base form. The word I, this is PRP, can is MD, swim is VB, the is determiner, fish, noun, can, MD, and swim is verb. If I have this data, now I want to check. I want to create the model. Okay, so I can create the model using some kind of probability function. With this probability function, then we can check. If I have a new word, he can swim. If I have another word, he can swim. So what is the prediction of he? What is the prediction of can? And what is the prediction for swim? We need to predict the so the point-wise means for every single word. There's another kind of way to do the POS tagging. It is based on the probabilistic model. The probabilistic model means we want to find the most probable tag sequence. So let's say I have the word natural language processing. So if the word natural followed by language, so we want to check what is the probability. The probability, the word language, when the first word is natural. Then if the probability is high, and yeah, we can define what is the tag. Or we can also make a different probability. What is the probability where the NN, this is the tag, it is followed by JJ. And if we have the probability, high probability, then we can check that this is JJ and this is NN. We can use with the generative sequence model. With the generative sequence model, we are not using only the probabilistic, but we use the Bayesian rule. So the Bayesian rule is the same with the probability. The probability of y given x, it is the same with the probability of x given y multiply the probability of y and divided by the probability of x. Okay. So here we have the arc max. We have the arc max. What does it mean? We want to choose the highest because the probability can be low. So we will do more with this one later with the text representation. So this is an example. It looks like chocolate. So it is PRP, personal pronoun. Looks, it is VB or verb. Like, it is preposition or subordinating conjunction. And chocolate, it is noun. So for every this, we can present the probability. So the verb is starting. So the start is PRP. Okay, the probability is 1. Then we know that this will be always the starting or the beginning of the word because the probability is 1. After noun, this is n noun. After noun, 0, 0, 0, 0, 0, and 1. Okay, we know that the probability is high when it is ending. So this is start and this is ending. The ending of a sentence. In, okay, in preposition. After in, we will look, this is 0, it is 1, 0, 0, 0, 0. Okay, after the preposition, the probability followed by noun is 1. PRP. So in PRP, here we have 0, 0, 0 0.3, 0, 0 0.6, and 0. Okay, after PRP, it is followed by verb. It is 0 0.666. And then after PRP, it is followed by in the preposition. It is 0 0.333. And we can follow with the highest probability. PV. Verb is 0, 0 0.5, 0 0.5, 0, 0, 0. Okay, then after verb, if it is noun, the probability is 0 0.5, and if it is in, it is the preposition, it is 0 0.5. So 50-50 probability. So this is the probability for the generative sequence model. That's why when you deal with the ChatGPT, you can see actually behind the ChatGPT is a big probability of this one. So yeah, we can look at the word. Okay. The probability is about the sequence based on the grammar. Now it is the probability based on the word. What is the probability of the word it? The word it, in this case, the probability actually is 0.3333 because the word it can be in front, it can be at the end, and the place can be anywhere. The chocolate, the probability of being a noun is 0.6666. The word I, the probability of being PRP is 0.333 and so on. So this is the point-wise prediction model. So we need to generate this kind of model so we can predict. Okay, if I have the word chocolate, then it will be noun. If I have the word he, then the probability is PRP is 0.3. If I have the word circle, then I know that there is a probability of being a noun, it is 0.333. And we can make the probability model. So the probability model means from the starting of the language, okay, it will be started with PRP, personal pronoun. And then it will go to verb. So the PRP, it is 0.333 will be the word it. And then the PRP, the probability after PRP is verb is 2 divided by 3, 60%, 66%. After the phoebe, after the verb, there is a probability that it is in or the preposition is 50%. And in the verb, looks, it is a phoebe, it is a probability with 50%. And so on. So we can make this model to represent the POS mechanism. There are things on the syntax analysis. We can figure out the NER or name entity recognition. In name entity recognition, NER, it is a test of information extraction that seeks to locate and classify the elements in the text into predefined categories. So, for example, I want to know the name of the person. I want to know the organization. I want to know the locations, expression of time, quantities, and etc. Okay. So if I have the word like this one, based in the UK, okay, we know UK is location. Therapy, maybe we are not sure what is it, but based on this one, it is a company. It's a data engineering firm that provides services to organizations around the world since 2018. Okay, this belongs to them. So this is the name entity that we want to extract. In the beginning, maybe we can just follow like this kind of category like organization, person, product, work of art, 기관명, 인명, 제품명, 저작물명. But yeah, you can look at these literatures. There are many kind of name entity recognition. So there are some approaches for this NER. Most of the NER, it is followed by dictionary. So you have a kind of dictionary, such one, or you can make a rule. In many cases, we have a list lookup, or usually they just have like a database. It is a system that recognizes only entities stored in the list. The advantages is simple, fast, language independent, and easy to retarget. And disadvantages is the collection and pairiness of lists cannot deal with name variants and cannot resolve ambiguity. So for example, yeah, this is one of the lookup DC. This is Washington DC. Okay, this is about location. So I can define the location. So I can select entity. This one, deferred action for childhood arrivals. Okay, this is an organization. Department of Homeland Security. So this is an organization. And so on. So you can make this category based on the token. Or we can do the parsing. So the parsing means we are looking at the word based on the internal evidence. So these names often have the internal structure. These components can be either stored or cached. Let's say if it is a cap word, cap, 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 demunjak. Okay, so it's capitalized. So Wall Street, this is organization. But if you have the word in English, boulevard, B, it is the capitalized B. Okay, this is a road. Okay, this is location. Or you can have avenue. So this is location. Or if the word is road, then this is location. Or the word is question, this is also a location. So this is just a parsing without any specific details. Okay, so I think we already finished all the things. I will go to the Google Colab. Maybe I will explain it on next week. Okay. Any questions? Then okay, we can finish our